Now let's look at today's topic, which is on bipartite graph and assignment problem. So let's look at the scenario here. So you have a head chef in a kitchen, and this head chef, he have 3 tasks, right, to be performed, namely task 1, 2, and 3. And this head chef, he have 3 apprentice chefs, known as A1, A2, and A3. So basically, they will be each assigned a task. Okay, so based on the diagram here, right, it's actually showing you the apprentice 1, 2, and 3, and the tasks that they are actually able to perform. So if you look at the diagram here, apprentice 1 can complete task 1 and task 3. Apprentice 2 can perform task 1, 2, and 3, whereas apprentice 3 can only perform task 3. Now, if you study the graph, you will see that task 1 actually can be performed by apprentice 1 and 2, right? Whereas task 2 can be actually performed by only apprentice 2. Whereas task 3 can be actually performed by all the 3 apprentices. Okay, but then from the scenario given here, they say the 3 apprentices, they will each be assigned a task. They will each be assigned a task. That means only one person, one task. So which of these tasks can be only done by one person? So one very clear one is T2. So T2 is the only task where apprentice 2 can do. So that means this would be the most suitable one for apprentice 2 to perform. So if apprentice 2 is doing task 2, she cannot do the other task. Why? Because it says one person, one task, right? So that means apprentice 2, he or she will focus on task 2. Okay? Then we'll look at task 1. So it seems like task 1, because this apprentice 2 is busy doing task 2, that means task 1 is basically left only apprentice 1 to do. So that means apprentice 1 will perform task 1. Okay, and since apprentice 1 is performing task 1, he cannot do the task 3 now. Okay, then we'll go to task 3. So it seems like now task 3 is clearly being assigned to apprentice 3, right? Now with the scenario where you have one apprentice will be assigned a task, then we can actually make out the conclusion that apprentice A can only do task 1, apprentice 2 can do task 2, whereas apprentice 3 can only do task 3. So this is basically the findings based on this bipartite diagram. Now, if you still remember what you have learned under bipartite, now what is bipartite? Bipartite graph, there's always 2 features. First, they have 2 clear groups, 2 distinct groups, and the edge or the connection is only joining the elements in the first set with the element in the second set, not within the same set itself, right? And now we are going for the assignment or allocation problem. So the assignment problem is actually happening in different situations. For example, like just now we have apprentice with task, right? And then if we are going to for the manufacturing environment, you can have jobs assigned to machine. Or if you are having something like a delivery service, right, then you can have from warehouse to stores. Or when you are going for transportation problem, then you can assign a certain taxi to customer. So in all of these case, in each of the case, one agent is only assigned one task. So now for the assignment problem, where you have one task or one agent having only one task to be assigned, right? You have to find the best combination, right? The best way of matching, right? So the best way of matching, you have to optimize the stated objective. And the stated objective here is actually depending on the question. So, for example, let's say for cost, definitely you want to minimize, right? And then in terms of distance or time, you would want to minimize as well. So, if the stated objective is actually to minimize the cost, distance, or time, then you can look for the minimum solution because that is the optimized um, objective here. But what if the question asks you for profit? Now, what would be an optimized situation for profit? Definitely, you go for the highest. So, the objective of the question, please do take note because each of the approach will be different. If it's going for the minimum, you will use a different approach, whereas for maximum, you will use a different solution method. Now let's look at the example 15. You have four footballers and they play for all the clubs here. So you have players and club and you are supposed to draw a bipartite graph. So bipartite graph here you have two groups. The first being the player. So this is on the left, I'll put the player. So this is David, Jason. So this is Ted. The next one is Ted. And the next one is Roger. And on the right, I have tigers. And then I have magpies. And I have bears. Those are the crop. And I have bulldogs. And I have the next one, which is bombers. Okay, so David played for club, tigers, and magpie. Right, play for the arrow. Same goes to magpie. Jason played for bears and bulldog. Ted played for bulldog, whereas Roger played for bombers and bear. Bombers and bear. There you go. This is the bipartite graph. Now from the example 16, the company has to allocate three tasks, namely task 1, 2, and 3, to match three employees, namely A, B, and C. And the times here is actually given in minutes. So they want you to match the task to the employee so as to minimize the total time. So you are going to focus on the task and you want to minimize the time. So let's look at task 1. Which one is the least time for task 1? So it seems like 6 is the least one. So I'll pick this task 1 to be done by employee B. Task 2, the smallest is 4, and it will assign to employee C. Whereas task 3, the smallest value here is 5, and it will be assigned to employee A. So for A, task 1 is completed by B. And you have task 2 is completed by C. And you have task 3 is completed by A. Right? Now the next thing you have to do here is to find the time to complete all the 3 tasks. So I just highlight the keyword here. The time required to complete all the tasks here. Now let's look at B. Right, the time required to complete all the 3 tasks. So A worker does task 3. How much time is here? It's actually 5 minutes. Okay, and then B worker or employee does task 1. Yeah. So it will take him 6 minutes. And let's look at employee C. He's actually doing task 2. What are the time frame here? For task 2 is 4 minutes. So what is the complete time? The total time to complete all the tasks, you have altogether 15 minutes.